Hi everyone. So I'm going to walk you through trig lesson number 2 in this video, and it's going to be where we're going to be solving for sides and angles in right angle triangles. And so just a brief review of what we learned yesterday about these trig ratios or trig fractions, so that for any right angled triangle, so if you have a right angled triangle, and you'll always recognize that you have a right angled triangle by the fact that there's that little symbol in the corner. We know that there are ratios of the sides, and they depend on which angle you're looking at. So if I was looking at this angle in the corner, the side that is opposite the right angle is called the hypotenuse. The side that's opposite the angle I'm looking at is called the opposite side, and the side that's adjacent to the angle we're looking at is called the A, or the adjacent side. So, and from those, the ratios are called sine, cos, and tan, and so sine of theta is equal to the opposite side over the hypotenuse. The cos of the angle is equal to the adjacent side over the hypotenuse, and the tan of the angle is equal to the opposite side over the adjacent side. So those are what we call the primary trig ratios, or the primary trig fractions. All they are, ratios are just fractions. And you get those fractions by doing ratios of different sides over one another. So opposite over hypotenuse. And that's why we call that one so. S, sine, is opposite over hypotenuse. And cos, is adjacent over hypotenuse. And tan, or toa, is opposite over adjacent. So we have this quick memory tool of so, ka, toa for remembering these primary trig ratios. And what we're going to do in today's lesson is learn more about how to apply those to solve for a missing side or a missing angle. And that's what we're going to be doing here. Okay, well, let's get started. So let's start by using our primary trig ratios to solve for an unknown side. And so I've given you an example of a triangle here. I'm just going to try to make it a little bit bigger so you guys can see that. And in this case, we're trying to solve for side A. Often it'll be indicated as an X or a Y, but in this case it's indicated as an A. So we're interested in that side of this triangle. And notice that we've been given this angle 43, so we've been given this angle, and we've been given one side. Now, normally in math, you've learned how to solve for sides using Pythagorean theorem. And Pythagorean theorem says that a squared plus b squared is equal to c squared. And so you might think, well, why couldn't I just use Pythagorean theorem in this case, where this is my shortest side and my other shortest side, and then this is the hypotenuse of the longest side. But you notice in this case, we're only given one other side. We don't know the hypotenuse in this case, and so unfortunately, Pythagorean theorem won't work. But we've always got that in case we do need it. So I'm just going to cross it out because unfortunately we can't use it. And I'll just write a little note here, can't use. Okay, but what we can use are our primary trig ratios. And so let's label this diagram, label the triangle, according to the angle 43. So we're going to label it relative to this angle. So side AB, I'm going to label the hypotenuse. It's opposite the right angle, and so it's the hypotenuse. Now, according to 43, my unknown side, which is A, is the opposite side. It's opposite to 43, and the AC is adjacent to the 43. So notice, this is what is key to solving triangles, is that I notice that according to 43, I know the adjacent side. I know its length. Okay, so I'm going to circle those two. Those are going to be important. I know that number, so I need to include that number. And the number I'm looking for is the opposite side. So in this case, I'm really interested in the O and the A. And so when I think about my primary trig ratios, I think about SO, Ka, and TOA. The side that I'm trying to solve for is opposite, but I have information about the adjacent. So look at this, it's O and A. So I'm interested in tan. Notice that I don't know anything about the hypotenuse. So really, I don't want to use the sine or the cos in this case because I'm interested in the opposite and the adjacent. So watch what happens when I write it. I write tan of the angle. Well, the angle is 43, so tan of 43 degrees is equal to opposite over adjacent. That's what the trig ratio tells me. And now I'm going to put the numbers in. So tan of 43 is equal to the opposite side, which in this case is our unknown, which is A, over 11. And now all of a sudden, I've got a little equation that I need to solve. Okay, so here we go. I am going to, I need to get A by itself. And so I need to get rid of that 11. So what I'm going to do here is I'm going to multiply this side by 11 to get rid of it. Remember, you do the opposite operation, but whatever you do to one side in math, you've got to do to the other side. So 11 times both sides. Well, 11 divided by 11 equals 1, so that gets rid of it. And so my A is going to be equal to 11 times tan of 43. Okay, so at this point I go to my calculator, and I'm going to go to my online calculator here, and I am going to type in tan of 43 and hit equals. And I notice that that negative gave me I'm not in degrees. Let me get to degrees. So there, make sure your calculator is in degrees. So here we go again. Tan of 43 equals, there it is, 0.9325. Okay, so let me go back, and I'm going to go 11 times 0.9325. And now I go to my calculator and I type that in. Here we go. And I've already got the 0.9325 there, so I'm just going to go times 11 equals, and I get 10.257. Okay, so my A is equal to 10.257. I'll say 10.257. I'll round that up to 10.26. And then I look at my diagram and I make sure that that's reasonable. And sure enough, yeah, that would be a reasonable number for that side. Okay, so that's how you use the trig ratios to solve for unknown sides. Okay, well, let's go ahead and do solving for an angle. So I'm going to go to the next page. And this one says using trig ratios to solve for an unknown angle. Okay, well, let's look at this triangle. And in this case, I'm looking to solve for the angle x down in this corner. All right, so once again, I notice that I'm given two sides here. So I am going to label my triangle using my opposite, adjacent, and hypotenuse, but I'm going to do it relative to this angle x. So I look and say to myself, okay, well, 32 is the hypotenuse, and I know that because it's opposite the right angle. Now, according to x, the 15 is the adjacent, okay? And this other side over here is the opposite. Now, notice that I'm not given any information about the opposite, so I probably don't want to include that in my trig ratios. So really, I know the adjacent side and I know the hypotenuse. So let's look at our primary trig ratios, so Ka and TOA. And sure enough, I see that the A and the H are with cos. And so that's the one I'm interested in. So watch this. I write cos of the angle x, which is my unknown, is equal to adjacent over hypotenuse. That's what that means. AH, it's adjacent over hypotenuse. That's the ratio. And so watch, I'm going to now sub my numbers in. So cos of angle x is equal to adjacent, which is 15 divided by 32. Okay, so now let's go to our calculator. And so cos of angle x is equal to, I'm going to type in, I'll just clear it here, 15 divided by 32 equals 0.46875. 0.46875. I think that was what it was. 0.46875. Good. Okay. And now I need to get rid of the cos because I want the angle. I don't want cos of the angle. I want the angle. So this is where we do that little thing where we do the inverse. And so to move the cos over, I'm going to do this little operation called the inverse. Sorry, guys. Cos -1 of 0.46875. And my calculator will do this little inverse for me. So watch this. I go to my calculator, and I am going to type in there. I'm just going to clear all this. And I'm going to go inverse or second. A lot of you have cell phones, and it'll be second. So I do this. And now just ignore the fact that it says arc cos. It just means cos -1. And I want to do this calculator. I can hit answer there, which remembers it's 0.46875, which is kind of nice. And I hit equals. There it is, 62 degrees. And so the answer here is 62 degrees. All right, so that's how we do this when we're solving for an unknown angle. So you've now tried it. Well, let's try a couple of application questions here. Okay, so this is, because part of your homework is going to be to do an application question. So this one says, you work for an oil company, you need to drill a well to an oil deposit that lies 2,300 meters below the bottom of a lake, which is 150 meters deep. Because of this, the well needs to be drilled at an angle from a site on the land, and the site that you have picked for the well is 1,000 meters away from a point directly above the deposit. Okay, so what angle do you need to drill at? Well, they kind of give you a hint here with this picture, but the first thing you want to do is do a drawing. So here, I'm going to put my well right here. This is where I'm going to start drilling. And it's told me that I'm 1,000 meters from the point directly above the deposit. So I'm going to go across here, and that is my 1,000 meters. So really, it's from here to here on that diagram. Okay, now, the other thing I've been given is it says that the deposit is 2,300 meters below the bottom of the lake. So you've got a little lake here, which is 150. So that's this little distance right here, which is 150 meters. But then the deposit is way down here, and that is 2,300 meters. Okay, so just, oops, I'm not sure why that was moving around. Let's try this again. 2,300 meters. Okay, so we know then that that whole distance there, when I add those two together, is 2,450 meters, and that's the whole distance from the top or the center of the lake right down to the deposit. Sorry, I should show it like that. So that's 2,450. Okay, and what I'm interested in, I'm just going to join this. I'm interested in that angle. I'm going to call it theta. That's the angle that I'm interested in. All right, so once again, we need to label our triangle. We need to start by labeling. And so relative to that angle, and I know it's not labeled on here, but I'm going to label it. I know that that's got to be a right angle, because when you look at this triangle, you are going to drill straight down and the surface is straight across. So sure enough, that's right angle. So we know we can use our primary trig ratios. Okay, so relative to theta, the 1,000 meters is adjacent to it. And the 2450, this side over here, is opposite. Okay, so do I use so, ka, or toa? Well, of course, I think you guys would all recognize I'm going to use toa because it's got the O and the A. I don't know anything about the hypotenuse in this case. So watch this. I am going to write tan of theta is equal to opposite over adjacent. Tan is opposite over adjacent. So let's sub our numbers in here. So tan of theta is going to be 2450. That's opposite divided by 1,000. Okay. And so when I divide those, I determine that tan of theta is 2.45. And now I need to do that inverse tan. So theta is going to be the inverse tan of 2.45. And our calculator will do that for us. So let's go to our calculator. Okay, and so I'm going to clear everything, and I'm going to go inverse tan, and that's the inverse tan, and I'm going to put in there 2.45, and I hit equals. And I get a number of 67.79, so I'm going to say that's approximately 68 degrees. Okay, so let's go back. And so it's approximately equal to 68 degrees. And I look at my diagram. Does that make sense? Sure, it does. That's approximately, that's somewhere between 0 and 90. It makes sense that that's 68 degrees. And so therefore you would drill your well at an angle of 68 degrees to get to the deposit. Okay, let's try another one. So this one says foresters use something called a clinometer to measure the angle of elevation to the top of a tree. So if you're going to try to estimate the height of a tree, you're standing 7.2 meters from a tree and your eyes are 1.6 meters above the ground. How tall is the tree? All right, let's start with a diagram here. So we'll draw the ground. Here's the ground. Here's where I'm standing. Okay, I'm standing over here. There's my eye. And I'm looking at this tree. And so I'm going to draw a tree over here. Okay, this is obviously a coniferous tree, so a pine tree. And so first up, the clinometer is held up to my eye. So I've got to put a kind of a dotted line across there. Okay, because my eyes are 1.6 meters above the ground. So look at this. That distance there is 1.6 meters. So I'm going to have to add that in at the end. So I know that I'm missing that 1.6 meters. But using my clinometer, I'm going to be able to measure. And look at the right angle triangle I'm going to draw here. I'm going to draw right. Oops. That wasn't very good. Let me fix that. One more time. There we go. And there's the right angle. So what I'm going to get using my clinometer is I am going to get this distance right here. And I'm going to label this distance X. And that's from here down to here. Okay. But what else do I know is I know that I'm standing 7.2 meters from the tree. So really what I know is I know that this distance right here, the bottom of the triangle, is 7.2 meters. Okay, we're good to go because I know that this angle right here is 48 degrees. It says it measures the angle of 48 degrees. It's the elevation that I'm measuring from my eyes up to the top of the tree. Okay, so relative to the 48 degrees, let's label this right-angled triangle. And so I'm interested in this triangle right here, this right-angled triangle. And so the 7.2 is adjacent to the 48, and the side I'm looking for is opposite. Oh, so this is cool. I'm interested in tan again. TOA, because I've got I need the opposite, and I've got the adjacent. So I write here, tan of 48 degrees is equal to the opposite side, which is my unknown x, over 7.2. So now I want to rearrange this equation to solve for x. And so I'll start by multiplying this side by 7.2, which is the opposite of dividing by 7.2. But whatever I do to one side, I've got to do to the other. So I'm going to multiply that. So there we go. So in this case, x is going to be 7.210 of 48. Go to my calculator. I'll clear it. And I want to do tan of 48 degrees. And I get 1.11. So here we go. 7.2 times 1.11. And when I type that into my calculator, I get 8. So I know that this side right here is 8 meters, but remember we have to account for that 1.6. So 8 plus 1.6 meters is equal to 9.6 meters. So the height of the tree must be 9.6 meters. Height of tree. Okay, so your homework is here. You can see that I've given you the value, the questions right here. You're doing 4, 5, and 7. You're also doing 11, which I've indicated there, and 14. And I've also given you the answers from the back of the book. So as you do them, you can quickly check the answers. They're right here on the slides with you. All right, good luck, you guys.